Oops, sorry, I forgot to put me on. All right, today we're going to talk about zeros of polynomials. Where does it cross the x-axis? But we're also going to be looking at imaginary zeros. So zeros that exist but don't cross the x-axis. So they're like turning points that you can find, not really turning points, but parts of the wave that show you where it turns and gives you different information later on. And we'll see how that goes. All right, so we're going to find the rational zero to find them. We use that. We started with that last time. And I stopped with that last time. So you do the factors of the last divided by factors of the first. And then we're going to talk about, I think to show up, maybe, finding zeros of the polynomial function, solving the polynomial equations. We're going to do linear factorization to find all of them, and then Descartes' rule to actually help graph a little bit. That one is probably the least important out of everybody, but it does help us in the end run. Okay, remember, last time we took the factors of the last divided by factors of the first to find the possible rational. They were not all of them, but they were the possible. So here we would take factors of 4 and factors of 3, and we divide the factors of 3 by the factors of 4. So we took 1 divided by 1, 1 divided by 2, 1 divided by 4, and then 3 divided by 1, 2, and 4. And remember, we had the plus and the minus of all those, and that was the possible rationals. Okay, do yours, because you'll be needing them later on, so make sure you have them done right. So you had 1, 3, 5, 15, 1 and 2. So you took 1 divided by 1, 3, 5, 15, and 2 divided by 1, 3, 5, 15. Okay, those are the ones you're going to plug in later. So let's do this first one a little bit together. So if you have a table on your calculator, that works best. You just hit table mode, type in your equation. There should be -3 back here. You can't read it. And then if you don't, you can go to Decimals, you can download it, and there's a table mode on there that you can type in and it will tell you what the answers are. Or you can use your calculator and just keep changing out, like put parentheses where the x's are and keep changing out your numbers. So we're going to start here and try to find our thing. So we plug in -1, it is 6, 1 is 12, then we go to the 0.5, and 0.5 and -0.5 are also not 0. And then we keep moving and we finally come up with -3 as 0. So I know my first 0 is -3. I'm going to use that and create a smaller one like we did last time. So we're going to use our synthetic division. So -3 because it's not in factor form. Now we have 4 x to the 5th. We have 12 x to the 4th. I have no cubes. I have no squareds. I had -1 x's and -3. Now we want to factor this. Last one is our remainder. So we have 4, -12, 0, 0, 0, 0, 0, 0, -1, 3, and 0. Now I know there's only one x in here because this is a linear term. So this is really 4x to the 4th minus 1. Well, I know I have 4 more roots to find, but right now I can solve that. So I'm going to add 1. So you got 4x to the 4th equals 1. You're going to divide by 4. So x to the 4th equals 1/4. And then you're going to take the 4th root. Okay, that's a little ugly, I understand. So you're going to do that on your calculator. You're going to type the 4th root in, and you're going to get plus or minus 0.7. All right, and these are roots. Technically, there's 2 plus 7s and 2 minus 7s is what this is. So now we're going to go to our graph, and we're going to graph all these. Whoops. We have -3, which is our first one. Where did this go? So we're going to go to -3 here. We're going to have the plus and the -0.7, the positive 0.7. Okay, I know it starts negative, ends positive. So I'm going to start negative. I'm going to go down, up, down, up. This is what it could possibly look like. We don't know for sure. All right, now it's your turn. Pause and do yours. All right, you had already done the factors on the other page. You should have found -1 works. So you plug in -1 synthetic, you got 15x squared minus x minus 2. This one here was an factorable one, so I factored it instead of the quadratic formula, but both would have given you the same answer. So in -30x, which is -6x and 5, grouped, took out the 3x and 1, which was in common, set those equal to 0, and we got x equals 2/5, x equals negative 1/3, and don't forget the x equals negative 1 that we started with. So we go to negative 1, negative 1/3, 2/5, and we know it ends positive, so we sketch in our graph. Do better than mine. Mine's pretty ugly. Okay, pause and try yours. Whoops. All right, when we go through here, its factors are 2 divided by 1, so it's just plus or minus 2. When I plugged it in, I got 2 to work. We did synthetic division. I got x squared plus 3x plus 1. This is not factorable because factors of 1 cannot add to 3. So I use the quadratic formula. Now this time when you use the quadratic formula, it wasn't pretty because 9 minus 4 is 5, and you've got the square root of 5. So the square root of 5 we just leave, so it's minus 3 plus the square root of 5 all over 2. Minus 3 minus 5 over this 2. This is minus the square root. It's hard to see. And 2, the original that we found. So those are our 3 roots. And then we could graph 2 if we wanted. All right. I want to find all the roots, including imaginary. The nice thing about imaginary, if you get one imaginary, its conjugate is also a root. They always come in pairs. So when they give you one, they actually gave you 2. So I want to find all the roots of x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13. So first we start by taking factors of 13 divided by 1. So factors of the last divided by factors of the first. And we get 1 and 13. It's x to the 4th, so I know there are 4 possible that I'm looking for. All right, I plug those in, and I was lucky. 1 worked the very first time. So I plug in 1, and I do my synthetic division. Right now, I kind of want to check for multiplicity. So when you do that, this last 0 doesn't count. And this is my new one that I'm going to use synthetic division with. And I'm going to try 1 again, just in case. It may or may not work. 1, 1, negative 4, 13, 13, and 0. So we got another one. So now this here is my depressed polynomial. Well, since there's only 3 of them, I know that that's a squared. So this is x squared minus 4x plus 13. I know the factors of 13 are not going to give me 4 since it's prime and there's only 1 and 13. So now we're going to do the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac. Whoops, forgot my parenthesis. All over 2a. Okay, when you type that into your calculator, you should get, look at what that actually came out to be. Square root of minus 36, negative 36. So the square root of negative 36 is 6i. So now we have 4 plus or minus 6i over 2. And that's going to reduce to 2 plus or minus 3i. So now I have 2 imaginary roots plus my 2 ones. Oops. So the list of solutions should be written, my first one, my second one, to show multiplicity, 2 plus 3i, and 2 minus 3i, which gives me 4 total roots, 2 imaginary and 2 real. All right, try yours. First thing you should have done is the factors of 24 divided by 1, which is not bad because that's just what they are, right? So we're going to do 1, 2, 3, 4, commas are coming, 6, 8, 12, and 24. Okay, we're going to check them all up, 1 plus or minus. So plus or minus 1 did not work. When you plugged in your 2, you should have gotten a root, which is 1. Don't forget your 0 for your cubed. Minus 6x squared, minus 8x's, and 24. Whoops. 20. Here, let's erase that. 24 is my linear term. Okay, let's do our synthetic division. Remembering here's where my 0 should be. So 1, 2. Cannot write today. Here we go. 1, 2, 2, 4, negative 2, negative 4, negative 12, negative 24, which gave you your 0. All right, I still have 4, so I need to find one more rational before I can use the quadratic formula. So let's check for multiplicity and do 2 again. There it goes. Just in case. Remember, that's kind of like a 50-50 shot here. So I bring down my 1, 2, 4, 8, 6, 12, and we got lucky. Now I'm down to an x squared. So we have x squared plus 4x plus 6. Use your quadratic formula, and you should get. So x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, when you did that, you should have gotten 24, negative 8 inside. So you've got negative, which is 2, 1. Sorry about that. Okay, so now we got negative 4 plus or minus. So that's going to be 2i, square roots of 2 all over 2. So your final answer should be negative 2 plus or minus I, square roots of 2. So there's 2 answers, and don't forget our 2 2's that we found at the beginning. So we have all 4 of our solution sets here. Okay, next we're going to go backwards. We want to give you the factors, and now you give me what the polynomial was. So it's just factor times factor times factor if it's factorable, and an is your leading coefficient. So now we have to get things. So when we go here, you find a third degree term. So I know this is going to be an x cubed, so I need 3 factors is what this means. First one is negative 3. So that means his factor is x plus 3. Now the nice thing is they gave me I. Well, I know I also has its conjugate, so I know I'm given I and negative I because that's a conjugate of that. So that means I have an x plus the I. Okay, let's do this correctly so you don't get lost. So that means you have this direction. It's always x minus, right? So this was actually x minus a negative 3. This is x minus I, and then it's x minus the negative I, which makes that plus a positive I. Okay, now I have to take those 3 factors and multiply them together and then figure out what my leading coefficient is. So these are conjugates, so we know that's x squared minus I squared, which is plus 1. Now I have to take that times the x plus 3, and we get this. Next, we look at what they give us. They can give us the leading coefficient, or they can give us a way to find it. This time, they gave us a way to find it. The other way is a lot easier. You just type it in. So 1 is the x, so I plug 1 in for all my x's up here, and that equals 8. So that means an times 8 is equal to 8, because that's what this equals. Divide out, and a1 is 1, so my leading coefficient is 1, and my final answer is where I ended up. All right, let's try yours and see how you do. Okay, again, we have degree 3, which means I'm going to have 3 factors, correct? All right, the first one was 5, so I know that's x minus 5 when I put it into factor. The next one is 2 minus I, which means they also give me 2 plus I. So now I have x minus 2 minus I, and I have x minus 2 plus I. Okay, we have to distribute that negative before we can multiply, so that's x minus 2 plus I, x minus 2 minus I, and we still have the x minus 5 in front. When you get good at multiplying these, you can go straight to the answer, but until you figure out that pattern, you have to do it by yourself. So the first one, we distribute the x, so we have x squared minus 2x minus ix. Next, we distribute the negative 2, so I have another negative 2x, I have a plus 4, and I have a plus 2i. Next, I'm going to distribute the I, so I have a plus ix. I have a minus 2i. I'm just lining them up on the bottom here. And I am giving a minus I squared, which I know is, so minus I squared is the same as plus 1. So I'm going to put him under the 4. Add all this up, and we end up with x squared minus 4x And then 4 plus 1 is 5. Okay, all times x minus 5. Now we have to do that distribution. I am so out of room. So we're going to distribute the x through. I'm going to go over here. So you have x cubed minus 4x squared plus 5x. Distribute your 5 through, and you're going to get a negative 5x squared plus 20x minus 25. So your final solution here, before we plug in the 1, is x cubed minus 9x squared plus 25x minus 25. Now I know all of this is times an. And I know I'm giving that f1 equals 9. So this equals 9 when x is 1. So let's plug in my 1 here. So 9 equals an times 1 minus 9 plus 5, because you're plugging 1 in for all these x's, minus 25. So this time my an is, what do we have here? 6, negative 3, negative 28. I am sorry, I am so out of room. This is terrible. So that means an equals 9 divided by a negative 28. So all I do is I plug that back into here, and that is my equation. So, well, I guess we'll continue down. So now we have my f of x is equal to negative 9 over 28 times this where you started, x cubed minus 9x squared plus 5x minus 25. I'm actually okay if you stop there. Okay, that was a little confusing, but I hope you did well. All right, when we go through here, Descartes' rule is used just to tell you what the graph could look like. It's like how many times it crosses the x-axis, if it ends up positive or negative, those type of things. We have to test you on it, but you probably already know this. So we have x to the 4th, right? So I know this thing is the 4th is positive. I know it looks like this. Okay, the thing that Descartes' rule is showing you is the different options it could be. So right now I could have all 4 of them crossing the x-axis, right? I could have it where this went down and touched and went back up, so you'd only have 3 real roots. I could have where it was way down here, so you'd only have 2 real roots. Or I could have where it's way up here where I have none. So there are a lot of different ways to draw that x to the 4th. What Descartes' rule does is kind of limits you to which one of those actually works, so you know what you're looking for. The first thing you do is you just look at the signs as is. So this is the positive section. It's how many times could it cross the x-axis. So we go positive, negative, this is positive, this is negative, this is positive. Now you count sign changes. So is it different from positive to negative? The answer is yes, there's one sign change. Negative, positive, yes, there's another sign change. Positive, negative, yes. Then negative to positive, yes. So we have 4 sign changes. So I could have 4 possible roots. Okay? And negative is when you let it be negative. So now I plug in f of negative x and see what we get. So we have negative x to the 4th minus 14, negative x cubed plus 71, negative x squared minus 154 times negative x plus 120. If you find a shortcut, you're welcome to use it. So this is positive when I square it, because negative x to the 4th is a positive number. Negative x cubed is negative, but a negative times a negative is a positive number. Negative x squared is positive. Positive times a positive is positive. Negative times a negative is positive, and a positive 120. Now you count sign changes again. No, not different. No, not different. No, and no. So we have 0 negative solutions. The imaginary is what the difference between possible and here. So this row has to add up to your highest exponent. So whatever I need to add to 4 in this row is what I put here. But 4 plus 0 is already 4, so there are no imaginaries. Now, when you look at loops, there's always two sides to a wave. So you always take out 2. So the next direction says you subtract 2 by an even number. So I subtract 2, and that's what could be left. But you can never go below 0 or 1. So once you get to 0, you're done. So 4 minus 2 is 2. I can't subtract here. And then this guy has to add to 4. So there's 2 left. So this whole thing equals 4. All right. Now I subtract 2 again. So this is 0, 0, 4 imaginary. So this is telling me my graph could look like all 4 crossing the x. It could look like 2 of them crossing the x, or none of them. So it took out one of my options. That's all it's doing. Okay, your turn. Whoops. So you do it as is. So positive, positive, negative, negative. There's one sign change. So the positive is 1. So I put a 1 here. Now we do negative. So you do f of negative x, and we get 3 negative x cubed plus negative x squared minus 6 times negative x minus 2. Now we're looking at the signs. Negative cubed is negative times a positive is negative. Negative x squared is positive. Positive stays positive. Negative times a negative is a positive and negative. So now my sign changes go like so. One sign change, not a sign change, one sign change. So I had 2 negative. This thing has to add. 3 is my total because that's my highest exponent. So I have no imaginary. Now we subtract 2. I cannot subtract 2 from 1, so that stays 1. 2 minus 2 is 0. And I need to add to 3, so there's 2 there. All right. I hope you do well. Good luck on your homework.